Welcome to the Daily Globe. Please subscribe and hit the bell icon for more breaking updates. In the vast theater of the cosmos, a rare and extraordinary event has just unfolded. A traveler from another star system, known as 3I Atlas, swept past Mars. This interstellar visitor, moving at unimaginable speeds, has journeyed across the void for millions of years before arriving in our solar system, making its close approach to the red planet a truly historic moment for science and humanity alike. This isn't just another rock drifting through space. It's a cosmic messenger, carrying secrets and clues from a distant stellar neighborhood. Its composition, trajectory, and origins could reveal untold stories about the birth of stars, the formation of planets, and the mysterious processes that shape galaxies far beyond our own. Our robotic explorers stationed at Mars, rovers and orbiters alike, were perfectly positioned to witness this fleeting encounter. Their instruments were primed, ready to capture every possible detail, from high-resolution images to chemical signatures, data that could fundamentally reshape our understanding of planetary systems and the origins of interstellar objects. Around the world, scientists, journalists, and space enthusiasts alike waited with bated breath for the first images and revelations from this once-in-a-generation flyby. The anticipation was electric, as everyone hoped to witness history in the making, and perhaps even catch a glimpse of something never seen before. But just as the drama reached its peak, a political impasse in the United States triggered a government shutdown, abruptly silencing NASA, the very agency at the heart of the mission. The timing could not have been worse, as the world's eyes were fixed on the skies, waiting for answers. The anticipated flow of images and data from Mars rovers and orbiters abruptly ceased, leaving the public, scientists, and even international partners in the dark. Screens went black, transmissions paused, and the promise of discovery was suddenly put on hold. This unexpected silence has created a vacuum, fueling speculation, uncertainty, and frustration. What should have been a moment of shared wonder and scientific progress has instead become a mystery shrouded in bureaucracy, with the world left to wonder what secrets might be slipping through our fingers. The story of 3I Atlas is now twofold, a tale of cosmic exploration and discovery, but also a cautionary reminder of how earthly politics can stifle our reach for the stars. It's a stark illustration of how the ambitions of science can be halted by the realities of government and policy. As we stand on the edge of discovery, we're reminded that our ability to explore the universe is only as strong as our willingness to work together, to support science, and to keep the lines of communication open. The cosmos will continue to send its messengers, but it is up to us to ensure we are ready to listen. To grasp the significance of this discovery, we must first understand the nature of the visitor that has captured the attention of astronomers worldwide. Known as 3I Atlas, this object is only the third confirmed interstellar traveler to ever enter our solar system, a truly rare event in the history of space observation. Like its famous predecessors, Oumuamua and Borisov, Atlas was born in the distant reaches around another star, shaped by forces far beyond our own sun, and then flung into the vastness of the galaxy by gravitational encounters. Its immense speed and sharply angled trajectory are telltale signs of its alien origin, evidence that it is a pristine sample from a remote and unexplored corner of the Milky Way, untouched by our solar system until now. By studying its unique composition, scientists have a rare opportunity to compare the fundamental building blocks of other solar systems to those that make up our own, potentially unlocking secrets about the origins of planets and life itself. Unlike the previous interstellar objects, Atlas passed unusually close to Mars, presenting a once-in-a-lifetime chance for our robotic explorers to attempt an up-close study of this cosmic wanderer. Instruments aboard Mars orbiters and the Perseverance rover were quickly retasked, poised to analyze the gases released by Atlas and, with luck, even capture a direct image of its mysterious core as it swept past. The scientific stakes were enormous. Could Atlas carry water ice, exotic minerals, or organic molecules unlike any ever found in our solar system? The answers could reshape our understanding of chemistry and biology across the cosmos. This extraordinary flyby was more than just a curiosity. It was a fundamental experiment in understanding how worlds are built, how materials are exchanged across the galaxy, and perhaps how life itself might spread among the stars. On October 3, 2025, 3I Atlas made its closest approach to Mars, just 12 to 30 million kilometers away. For a brief moment, this interstellar relic became a neighbor to Mars, and mission planners at NASA and ESA were ready. The Mars Reconnaissance Orbiter aimed its high-rise camera for the most detailed image ever of an interstellar object. MAVEN turned its spectrographs to analyze the object's chemical makeup, while Perseverance pointed its cameras skyward to catch a glimpse. Capturing Atlas was a technical challenge. Faint, fast-moving, and fleeting, yet the potential reward was immense. Data that could reveal whether Atlas was rocky, icy, or something entirely new. The world waited, abuzz with anticipation. The spacecraft executed their sequences, gathering photons from a visitor that had traveled millennia to reach Mars. The precious data was collected and stored, ready to be sent back to Earth. As this extraordinary cosmic event unfolded, a government shutdown in the United States brought NASA's public operations to a sudden and jarring halt. The timing could not have been worse, as anticipation for the interstellar flyby reached a fever pitch around the globe. Over 80% of NASA's workforce was furloughed, leaving only a skeleton crew to maintain essential systems. All non-essential activities, including public outreach, education programs, and real-time mission updates, ceased overnight, leaving offices eerily silent and hallways deserted. The NASA website, streaming service, and social media went dark, just as the world eagerly awaited news and images from the historic interstellar encounter. For many, it was as if a digital blackout had swept across the agency. Robotic missions continued collecting invaluable data millions of miles away, their instruments humming in the void. But the scientists and engineers needed to process, interpret, and share that data with the world were sidelined, unable to communicate their discoveries. NASA spokespersons could only offer reassurances that the mission was still on track, promising that the data would eventually be released after the shutdown ended. But for now, the flow of information was frozen. The timing was devastating. The public's imagination had been captured, classrooms and families gathered in anticipation. But instead of awe-inspiring images, they faced only silence and uncertainty. The sense of collective wonder was replaced by confusion and disappointment. The shutdown drew a curtain across the cosmos, not for technical reasons, but due to political gridlock in Washington. The fate of scientific discovery was suddenly entangled with the fate of government negotiations. The stars continued their ancient dance above, indifferent to our troubles. But our window to them was abruptly and unexpectedly closed. The tools we built to explore the universe were left idle, locked away behind bureaucratic barriers. The world was left waiting, wondering what discoveries were being kept from view, and what moments of inspiration might be lost forever. Scientists, students, and space enthusiasts everywhere felt the weight of missed opportunity. In that silence, the opportunity for shared wonder slipped away, a reminder that sometimes the greatest barriers to exploration are not found in the stars, but here on Earth. As NASA went dark, the European Space Agency stepped up, releasing the first official images of 3I Atlas from the ExoMars Trace Gas Orbiter. The image, a faint dot against the black of space, confirmed the flyby had been observed, keeping the flame of discovery alive. ESA's actions highlighted the value of international collaboration. When one partner falters, another can carry the torch. Meanwhile, citizen scientists seized the moment. Before the full shutdown, raw data from Perseverance was uploaded to public archives. Amateurs like Stefan Burns and Simeon Schmaus analyzed these files, revealing the interstellar visitor as a streak of light in the Martian sky. Their work demonstrated the power of open data and the democratization of discovery. Even as institutions faltered, curiosity and ingenuity found a way. The glimpses from ESA and citizen scientists are just the beginning. The most valuable data remains locked on NASA's servers. The high-rise camera may have captured the nucleus of Atlas, key to understanding its true nature. Even more crucial is the spectroscopic data from MAVEN, which could reveal the object's chemical makeup and potential for organic molecules. Until this data is released, the central questions about Atlas remain unanswered. The delay isn't just frustrating, it stalls global scientific progress and collaboration. Upcoming observations by other missions like ESA's JUICE depend on insights from the Mars flyby. Each day the data is withheld is a lost opportunity for discovery. Our ability to collect cosmic treasures is extraordinary, but our systems for sharing them are fragile. The world waits, hoping the key to this locked trove is returned before the moment passes. The silence around the Atlas flyby exposes the uneasy relationship between science and politics. NASA, long a gold standard in international collaboration, now appears vulnerable to domestic disputes. Partners and the public alike are left questioning the reliability of the United States as a scientific leader. The information vacuum breeds speculation and erodes trust, both at home and abroad. In an age of misinformation, official silence is quickly filled by rumor and doubt. The shutdown is a stark reminder. Scientific progress depends on stable, open societies as much as on technology. The greatest obstacle to reaching the stars may not be physics, but our own inability to cooperate. For scientists, the Atlas flyby was a rare chance to test our understanding of the universe, yet the shutdown turned excitement into frustration. The delay in data release risks not just postponing discovery, but diminishing its impact. Scientific momentum is fragile. When the world's attention moves on, opportunities for inspiration and support are lost. This event exposes the vulnerability of publicly funded science to political shocks. Perhaps it will spur stronger international partnerships and more resilient systems for sharing data. The story of Atlas and the shutdown will be a footnote in history, but a telling one. Discovery is more than collecting data, it's about sharing and understanding it together. The future of exploration depends on openness, collaboration, and safeguarding science from the storms of politics. The saga of 3I Atlas and NASA's silence is a mirror of our aspirations and limitations. We can send robots to greet a visitor from another star, yet be silenced by our own disagreements. The universe is full of wonders, but our window to them is fragile. We must treat data from public missions as a global good, accessible to all. The work of citizen scientists shows the power of open knowledge. Let this story be a catalyst for building systems that protect the flow of discovery from political interference. The cosmos invites us to wonder and explore, but to answer, we must keep our own house in order. The secrets of the stars await. We simply have to keep listening, together.